Okay, let's just say we've got two cosets. We've got AH and we've got BH. And of course A and B are in the group G, and H is a subgroup of G. So I want to know if these are equal. You'll recall from the last screencast that two cosets are either equal or disjoint if these are equal. Okay, well the condition is AH as a set equals BH as a set if and only if A minus 1B is a member of H. So there's a condition. So if A minus 1B is a member of H, then AH equals BH, and if it's not, if this is not the case, then these two guys here are disjoint. Okay, so well, let's just prove the first one first. Oh no, that's not right. AH equals BH, and I want to show that A minus 1B is a member of H. So we start with this guy here. Oops. So we start with this guy here. AH equals BH, and I'm going to multiply this relationship here on the left hand side by A minus 1. A minus 1 AH equals A minus 1 BH, and of course by associativity and inverse elements this is just H equals A minus 1 BH, and so we know that this guy here is a member of H. A minus 1B is a member of H. QED, because we were trying to show that. Now we'll go the other way. Now I'll assume that A minus 1B is in fact a subgroup. Is in fact a member of the subgroup A, and I want to show that AH equals BH. Well, oops. Well, if this is the case, then I know that A minus 1B equals H for some H in H. Okay, so A minus 1B equals H for some H in H. So that tells me that B equals AH. And so I know that BH equals AH capital H. You see what I'm doing here? I'm just applying the definition of coset again and again and again. This is for some H, and I don't know which one it is, but it doesn't matter because I've just called it little h, and that's the end of it. So BH equals that, which equals A, and then I'm going to bracket it like that. And then we use the fact that capital H is a subgroup of GH to show that that's equal to AH. So BH equals AH, QED. So let's just review what we've got here, because there's quite a lot of meat on this. I've got two subsets, AH, two cosets at least, AH left cosets equals BH. No, I don't know that they're equal. I've got two cosets, AH and BH. And so these are equal sets if A minus 1B is a member of H, and disjoint because you'll remember from the last one that two cosets are either precisely equal or got no overlap at all, or disjoint if A minus 1B is not a member of H. There you go. That's quite nice. So not only do we know that two cosets are either equal or disjoint, we now got a criterion, which is this thing here, which specifies whether or not that's the case. Sorry about the ducks. I'm outside in a field at the moment. Okay, stop there.